Okay, now we shall be talking about the rates of change. The rates of change. No, actually, what happens is, okay, you apparently have an equation in y and x, okay? But you can have, for example, there is a curve like this. It's like this, okay? You see that from, let's say this is x, your x is 0 over here, and here your x is 10, okay? Your y is, let's say this is 20 over here, and this is, the y is 0 at this point. So what is happening with the passage of time? Your x coordinates are increasing from 0 to 10, and your y coordinates, they have decreased from 20 to 0. Okay, or you can have, like, these days, the corona situations, like, with the passage of time, it's going somewhere, it is going like this. And in Pakistan, alhamdulillah, like, this goes sometimes like this and then goes down, and, like, so with the passage of time, you see that the number of patients, sometimes it increases, sometimes it decreases. Okay, so the rate at which corona is spreading, that varies. Okay, na? So if we just talk about the things in two dimensions, in x and y, so you see that here is a point x comma y. So the x coordinate is changing at a different rate, and y coordinate is changing at a different rate. Okay, so the rate at which x changes, that is called the rate of change of x, and the rate at which y changes, that is called the rate of change of y. Later in the year, when you will be on to the mechanics, inshallah, there you will see that the rate of change of displacement, that will be called the velocity. You will be doing that in mechanics, kinematics. So the rate of change of the velocity, sorry, I had to say, sorry, just let me write this. That will be acceleration. The rate of change of velocity will be the acceleration, and the rate of change of the displacement, that will be the velocity. So we are basically going to talk about the rates of change right now. Okay? Achha, in this particular exercise 8D and the exercise following this, the thing is, look at this question number 1, for instance. Let me enlarge this a bit. Okay. And let me have some space for working here. Let me cover this up. Okay. If you look at this question, guys, here it says uh, a point is moving along the curve y is equal to 3x minus 2x cubed in such a way that the x coordinate is increasing at 0.015 units per second. So he's giving you the rate of change of x over here, and you will note it down in mathematical notation as dx by dt, that is equal to 0.015. And suppose if it was a decreasing rate, then you had to put a minus sign with this. Okay, so this is the increasing rate of the x coordinate, so that is your dx by dt. It says find the rate at which the y coordinate is changing when x is 2. It's asking for the dy by dt. But the thing is, you see that your equation is purely y in terms of x. There is no t over here. Okay? So how to bring in this t in our lives here? So for that purpose, we'll be using the chain rule. The chain rule helps us to connect one fraction as a, write one fraction as a product of two or more fractions. For example, if I have a over b, I can write it as a over, and I can write anything in these two slots, but that has to be same so that, they cancel out and I still get that a over b. So this a over b can be written as a over c times c over b. That is a chain rule. You can even write this a over b as a product of three different fractions. For instance, if you want to say this is a over b, so this is going to be a over x times x over y times y over z times z over b. So you see this a over b has been written as a product of four different fractions. So we'll be using this chain rule over here, bacho, to find this rate of change of y. Okay, now you see that if you have this dy by, sorry, this, you have got this y with you, and you, like, really like finding this dy by dx, so that will be 3 minus 6x squared. And then you have been given the value of x over here as well. Okay, you put that x into this. So at x equal to 2, like that is, for example, if you have the curve, like, something like this going on here. So here is the point where your x is equal to 2. Okay, at this particular point, the x coordinate is changing. I think, yeah, it's changing in this way, and we have to find the rate of change of y. So we need to put that x equal to 2 into this dy by dx. If I was to find the equation of the tangent, then I could have written this as m equal to this. So I'm not interested in the gradient right now. I just need to know what is this dy by dx. So this is going to be 3 minus 24. That is going to be minus 21. Okay, so we have dx by dt, we have dy by dx, and we want to know what is this dy by dt. So you will have to write your chain rule. So please tell me if I can really write this dy by dt as dy by dt. And let's write dx on these two slots. Anna? You see, this dy by dt is same as dy by dx times dx by dt. So using the chain rule, we are going to get this value of dy by dt. So you have dy by dx, that is minus 21. You have dx by dt, that is 0.015. Can you please multiply this for me? What do we get? 0. Okay, minus 0.315. So you see that y is decreasing at this rate, minus 0.315. That is the rate of decrease of y actually. Okay? So if you know the basic differentiation, you know how to differentiate using the first technique and the second technique, then this is simply a new thing that you will add into your learning, that is this chain rule. So through this chain rule, you're basically learning how to determine the rates of change. Okay? Now, let's go on to the another question here. Um, let me see where we have to find the rate of change of x. Okay, yeah, question number 7. Let's try question number 7, bacho. Okay, it says in the 7th question that a point moves along the curve y equal to this. So we have y equal to this. And I would be writing this as 8 into 7 minus 2x raised to power minus 1, because I know I have to differentiate it. Okay. This is 8 into 7 minus 2x raised to power minus 1. As it passes through the point P, the x coordinate is increasing at a rate. Oh, he's again giving us the x coordinate. Achha, एक second. Chale, let's complete this question and then we will go to another question. It says, as it passes to the point P, the x coordinate is increasing at the rate. So we have given the dx by dt, that is equal to 0.125 units per second. And the y coordinate is increasing at this. So we are given the rate of change of y as well. Oh, okay, that is 0.08. Find the possible x coordinates of P. Okay, so so you find this dy by dx. Okay, that will give you minus 8 into 7 minus 2x is from minus 2 times minus 2. So that is 16 over 7 minus 2x whole square. We have to find the value of x basically. So you can, like, say, okay, this dy by dx is going to be, so guys, can I write it as I put dt here and I put dt here? Dy by dx is going to be dy by dt times dt by dx. And this is 16 over 7 minus 2x whole square. Your dy by dt is 0.08, and you will have to write its reciprocal here. This is 1 over 0.125. Okay, so your favorite algebra comes in action here. So this is going to be um, 16 times 0.125 over 0.08, that is equal to 7 minus 2x whole square. So 7 minus 2x whole square is equal to whatever you have, you take the square root. So that is going to be plus minus. So what do you have here? Have you taken the square root? First tell me what is 16 into 0.125 over 0.08? Huh? 0. 25. Okay, they say we get 25. So this will be plus minus 5 here. So 7 minus 2x is either 5, and 7 minus, like you people are using the calculator, okay? So this is 2x equal to 2 and x equal to 1. This is 2x equal to 12 and x is equal to 6. So these are the two values of x at which you have these rates of change of the x and the y coordinate. Huh? What? Okay. So this was it. Now suppose you're given the rate of change of y and you have to find the rate of change of x. Okay. For that case, you will be writing your chain rule like this: dx by dt, and that would be dx by dt over here. Okay. And then you can write dy here and you can write dy over here. So this dx by dy is basically 1 over dy by dx, okay? And this will be given to you. So you get this dy by dx from the given equation, and then you have to remember, you have to write its reciprocal over here. Okay? इसका reciprocal यहाँ पे आएगा. So let's go on to the exercise 8e now. So we are here at exercise 8e. It says a circle has a radius r and area a. The radius is increasing. So it's giving us dr by dt. That is 0.1. The radius is increasing at this rate. Find the rate of change of increase of a. So it's asking for dA by dt when your r is 4. You see, no equation is given to you. But you have to see that we are talking about the area and the radius and the circle is there. So what can be your equation here? Yeah, area is going to be pi r square. So you will have to write the equation yourself. So area is equal to pi r square. So this is dA by dr. This is going to be 2 pi r. So you put r2 into it. So at r equal to, sorry, 4, r is given as 4. So this dA by dr is going to be 8 pi. Let it be in terms of pi right now, okay? And then you have to find this dA by dt. So this dA by dt would be dA by dt. And you know that this has to be dr over here. Hai? This is how you will find that. So your dA by dt would be dA by dr is 8 pi, and then dr by dt is 0.1. So if you have to give your answer in exact form, this has to be 0.8 pi. And otherwise, you can use calculators and write your answer correct to 3 significant figures. Okay? Achha, if you look at the second question, it says a sphere has a radius this and volume this. So what is the formula for the volume of a sphere? 4 over 3 pi r cube. So you will write it yourself, okay? Look at the third question. A cone has a base radius r and a fixed height of this. The radius of base is increasing. So you see, you will be dealing with the formula of the volume of the cone. A square has side x and area a. So area of a square is x squared. ठीक है? So you will have to try these questions now, ठीक है ना? Just spend some time on it and see where do you find difficulties. So we'll discuss that, ठीक है? Should I minimize this? You can, so that you can see more questions. Okay, so you try these questions, guys.